So what's the deal with that little table?
It's a first derivative. Is that
Um,
the first derivative test?
No,
No.
it's not the first derivative test.
I thought it was.
Who was it?
No, I thought it was.
Am I?
It shows the intervals for which it's, if it's going to be positive or negative.
Mm-hmm.
Or increasing or decreasing.
If it's gonna be an actual or random one at all.
You're just showing the well, that's three things.
Okay, it
That-
wanted to be the first derivative
You're
test anyway.
supposed to have.
It's not the first derivative test, no.
No, but like, when we do the first derivative
Uh-huh.
test, is a table, like, not like that.
A table similar to that, and why do we make those tables?
To have it down was more clear.
Yeah, it's just so it's more clear. That's all that, that's the answer right there. Just so it's more clear. Okay, so maybe to organize info. Because if you're just out there freewheeling it and you don't have a table of some kind, it's probably going to be a little confusing, a little messy, especially if we do functions that are a little more complicated than this, have multiple maxima and minima and maybe vertical asymptotes and all this different stuff. Okay, as we move on, it'll be a lot more information we got to keep straight. Okay, so once he found the critical numbers, what did Cornelius do with them that was incorrect? Sarah?
Oh, because he plugged the values in the original function and not in the derivative.
Should have been in the derivative. And so can we run through why that is? Why are you plugging them into the derivative and why?
We're trying to find out if the slope is negative or positive,
Uh-huh.
if it's increasing or decreasing.
You'll get a result, but it'll be a point.
The derivative is a formula, a function, or whatever that tells you the slope, right? What's that?
I said, if you plug it in, you're gonna get something, you're gonna get a point, but it's not at all gonna be what you're going to get.
Well, that's why we don't want to put it in here, right? Is that what you're saying? We don't want to put it in there. But the thing that tells us whether the function is decreasing or increasing, or one simple number that tells us whether it's increasing or decreasing is the slope. If the slope is positive, what's it doing?
Increasing.
And if it's negative, decreasing. If your slope is this way from bottom left to top right, it's increasing. No matter how severe that slope is, it's still increasing. The next value is going to be larger than the previous one, the next y value. Same with decreasing and negative slopes. Okay. So why are we finding where the derivative is equal to 0?
So you have,
For a horizontal.
Because you're trying.
so you have some information to start with, like a starting point, so you can go to the left and the right of that zero to see what.
Why don't we set it equal to 1 or 5? Or?
The zero to the left. It'll
What?
switch between increasing and decreasing.
Will it definitely switch between increasing and decreasing?
No.
No, sorry.
But
Isn't it?
It
because
might.
it's flat? The
it
derivative.
might. And is there anywhere else it might?
Number.
No.
No.
It only will switch when it goes through 0 slope. Otherwise, it won't switch. If it goes to 1, it doesn't mean anything. It could just keep that 1 forever. It could get steeper. It could get less steep forever and never reach 0. The only place where it will switch, which is what we're interested in, is where the derivative is 0, where the slope goes flat. Yeah.
And so if this was a different kind of problem, I don't know what it would look like, I guess, but if it was means, we just have the slope between the 2 points and set it equal to that rather than 0?
Yeah, that'd be a totally different problem. That'd be a mean value theorem problem. Previous section, exactly right. Should have used. Okay. So we're throwing around the first derivative test, and the first derivative test is so close to this that it would be, completely understandable that you would mistake this for the first derivative test. Do you remember what you wrote down in your notes? I asked you to write specifically down the first derivative test is used for
To find extreme f.
find extrema. Did we find extrema? Is that what we did? Is that what the conclusion Cornelius drew?
Mm-hmm.
No. Could he? well, not really, because he didn't actually find the correct values of the slope, right? If he had plugged them into h prime and found the correct values of h prime and found whether it's increasing or decreasing off of that information, once he's found that information, he could draw the conclusions of maxima and minima. And that would have been the first derivative test. Once you make the conclusion based on the slopes that you have a maximum or a minimum, that's the first derivative test. Okay. So it's going to be the second derivative test. The second derivative test finds the exact same thing, maxima and minima. It just does it differently. Okay. All clear on that? Crystal clear. Okay, so here's the next one. So you can see that Kaylin has done some work here. So Kaylin does this first, and Kaylin crosses out her original derivative, and then rewrites the original function y, and I guess it's kind of subjective as to why that is. You can answer what someone's motivation was, but why do you think? Write that down. The little hands. High school.
I have big hands. Follow that?
Are you writing anything down with your big hands? Well, that's the good.
My hands are actually very small.
Okay, well, you're a liar.
Small as usual. That's right.
That's racist.
You're just telling me that most of you that's why I'm using statistics and stuff.
So, why do you think she did that? She took the derivative, right?
She thought it would have been easier to calculate the derivative.
Okay, what's she gonna have to do with the derivative once she takes the derivative?
Set it equal to zero.
Set it equal to 0. So you try and take that first derivative, set that equal to 0 and solve it?
The button.
Yeah, even the button. I don't like it. So what she did instead was take f, the original f, and then multiply those two together, right? And do x plus 2 squared, then multiply x minus 1, and get a new function, a cubic function, and take the derivative of that. Much easier to take the derivative instead of equal to 0 and solve. Now, she could have taken the derivative, multiplied those first two parentheses together, distribute the 2, then multiply x plus 2 squared, then add all that together, combining like terms, got the same thing. But it wouldn't have been as easy to use. Okay? So if you're asked to take the derivative, probably just faster to take the derivative using the product rule, but if you actually have to do something with the derivative, it'd be easier to rewrite the original function. So it's easier to use derivative of the derivative function. Podium?
Yeah,
That gray one.
the gray one.
Nice. Yep. Okay, and second question, why are Kaylin's maximum and minimum values incorrect?
Are they only relative?
Did not do that right.
She didn't want to look at the original function.
No? What do you mean by she didn't plug them into the original
She
function?
didn't plug the negative 2 into the original, like fx.
Oh.
Or fx2 equals 2 plus 2 squared root.
Well, it's negative 2 though, right?
Negative 2. Same difference.
Is that, well, is it some difference? Negative 2 plus 2 and 2 plus 2?
I meant to say negative 2.
Okay, you meant to say
Give me a
negative.
break.
I'm sorry.
She's in a bad mood today. She was beating me up earlier.
She was.
Okay, she's reading it now.
I'm pretty sure everyone thinks about
Get at me, so Okay, so is that, you think that's right? You guys agree that she didn't plug it in the original function? It says, if you take negative 2 and put in the original function, f of x, you get 0, you get 0. And this one, do you get 0? If you do. I don't think you do. Oh no, you do get 0. There it is, right? That prime is 0. 0 in for the original function, you get -4. Yeah, 2 plus 2, or sorry, 0 plus 2, that's 2 squared, is 4 times -1 is -4.
Oh, did you get like the minimum and maximum backwards?
Yeah. How, why backwards?
Because if it's increasing and then decreases, then it's a maximum.
So here is increasing, right? That's kind of what it looks in general, and then decreasing. So if it looks like this before -2 and this after -2, it must have had a maximum. And then likewise here, it's going down and coming up, so it must have gotten to a minimum. So this should be a maximum at -2, 0, and a minimum. Minimum at 0, -4.
Wow, yeah.
So increasing, decreasing would be a max. That's the 1, and then vice versa for the minimum. Questions from that or from the homework? In general? Any other questions? What's that? 58?
What are you doing? I'm getting it. Calm down.
Kylie, stop bothering her. She's angry.
What tonight?
Angry Callie, stop bothering her.
Yeah, you're welcome. Callie, you're welcome.
Thank you. Very,
Is
very
that what's
much.
happening?
Yeah.
Okay, let's go back and see what the directions were here. The graph of f is shown. Sketch a graph of the derivative. So sketch a graph of the derivative. So that's a function, and we want to sketch the derivative. What are some things that we might easily graph about the
There's a
derivative?
0 at the, there's a 0 at -1,
0 at, looks like -1. I'm not sure if it's a.
and then a 0, and then a +1.
What about here as well? Okay. Zero slope for all 3 of those. So when you want to do something like this, look at your maxima and minima. That's going to be a helpful little hint. Okay. Then what?
Where it's increasing and decreasing.
Okay.
Or like positive and.
So it's increasing here.
Yeah.
So it has what kind of slopes?
Positive.
Positive ones. So our values must be like somewhere up in here in that interval. What about here to here?
Decreasing.
Negative, so somewhere down in here, right? The actual y values of the derivative are down here, negative values for the derivative. And here,
Increasing.
positive values, and here,
Negative.
negative values. So we must have values down in here for the derivative, then up in here, and then they must come back down and meet 0 again, come down here, be negative values, and then be positive from then on out. So negative values, the actual y value. Don't pay attention to the slope of the derivative right now, but the actual y value is negative because we have negative slopes. And then positive slopes, negative slopes, and positive slopes. It doesn't have to be pretty, but should reflect at least the places where the slope is flat, 0, and where it's positive and where it's negative. So those are the things we're concentrating on in this section is the maxima and minima, increasing and decreasing intervals. Other questions?
24.
That's on the quiz.
Yeah. I know, I just have trouble.
You don't,
with it, so.
all together?
Yeah.
Okay, well, let's just go back to, please, look at the work that's been done here. So I took the derivative, decided not to take the derivative that way, a little too complicated, okay? So I took the original function, multiplied it out, x plus 2 squared, x squared plus 4x plus 4 times x minus 1. We multiply those together, we get x cubed plus 3x squared minus 4. Okay, take the derivative, 3x squared plus 6x. Okay, now in calculus, we've been doing this for a while, we get used to taking the derivative. Right, we do it all the time, and sometimes we do it without even really knowing why. Why are we taking the derivative right now?
Find the slope, tell whether or not it's increasing or decreasing.
So a very simple way to tell whether a function is increasing or decreasing, going up or going down, is to look at
The slope.
its slope. Just a single number, just the value of a number. You don't even have to know what the number is, you just have to know whether it's positive or negative. That'll tell you whether the original function is increasing or decreasing. So there's one reason we're taking the derivative. And how we do that is, if we have an increasing function and the slopes are positive, we want to find, break that into chunks. Where is it increasing, where is it decreasing? Okay? So the only place it's going to possibly switch from increasing to decreasing or vice versa is where?
At where slope is equal to 0.
The slope is 0. There's no way you can go from a positive slope or an increasing function to a decreasing function without first going through a 0 slope. Okay. We're talking about a continuous differentiable function here, of course. All right, so we find places where the slope is 0. At x equals 0, the slope is 0, and at x equals -2, the slope is 0 as well. Okay. So just from that, we can now make our little table here. Okay. -2 and 0, the places where the slope is 0, we can write those things down right away. And we leave space then for the intervals. From -infinity up to our first critical number. Between all the critical numbers, if we had 3 or 4 or 5 critical numbers, we would just go step in between them. At your actual critical numbers, and then from the furthest right to the greatest critical number on to positive 50. Does that make sense? Gentlemen here? Okay. Then we look at f prime. Mainly because in the end, if we find some points that actually are the values of a maximum or a minimum, it's already, the work is done. Okay, we actually know where it is. On an interval, we're not really going to say much about the value of f of x, because f of x has lots of values on an interval, right? So we don't really do that. We just forget about those intervals for f prime, okay? Because they're not consistent. There's nothing consistent about those values on those intervals. But at a certain value, we can find the value, or a certain x value, we can find the y value of that function. And we move over to f prime. F prime is the thing that's going to tell us whether we're increasing or decreasing, and if we ever do switch from increasing to decreasing or vice versa, we'll find an extreme, okay, a maximum or a minimum. So then, how did we determine that this was a positive slope and therefore an increasing function?
You plugged number within negative infinity to -2 into the derivative to find the slope, and it, in that case, was a positive number, which means it was increasing.
So does it matter what value you choose?
No.
What could you choose?
-3.
-3, -1,000. Anything that's less than -2. I chose -3. Probably, 99% of people would choose -3 because it's just to the left of -2. It's not a decimal. It's probably the easiest value to work with if you're just to guess at one. So we find that it has a positive slope at -3, which is on this interval, and so it must be increasing on that entire interval. Why does it have to be increasing on that entire interval from -infinity to -2? How do we know that it's not? Because it switches.
Because it doesn't have a 0, of course.
Because if it switches, we would have already found another 0, which we didn't. We had 0 for the derivative. Okay, so it's increasing on that interval. We'll do the same thing for this interval. We'll pick -1, right, on that interval from -2 to 0. Okay, it's decreasing there. It's got a negative slope. Come to this interval, positive slope. Maybe you pick 1. 1's pretty easy. And it's increasing because it had a positive value for the derivative. Is this all good? Clear? Anything up?
Yeah.
Okay, good. The value of f prime at each of these, is this a big surprise?
No.
Why is this not surprising?
That's what I'm only going from 1 where it switches to 1.
That's how we found -2 and 0 in the first place, is to make the derivative equal to 0. So of course the derivative would be equal to 0 at those places. And the last thing we do now that we have all this information is to look at, okay, this is increasing. That means that it's got a positive slope. It's going like that. that's at -2, then it has a 0 slope, and afterwards it has a decreasing slope. Okay, so this is like your x-axis. We have increasing, 0 slope, decreasing, negative slope. Right? So if it increases and then it switches to decreasing, it must have done something like that, because it's a differentiable function, which means it doesn't cut corners like that. It's nice and smooth. So it must have a maximum there, and by the same reasoning, or similar reasoning, decreasing to increasing, a decreasing interval to an increasing interval must be right in the middle. We have a minimum.
How long is this assembly?
Like 2 days long.
Yeah, 3 or 4.
All right,
do
sassy
we-
pants.
Can I just hop up on number 8?
Something on 8?
Yeah.
I didn't hear what you said, because somebody was calling me sassy.
Sorry, you are sassy pants.
So, it's fun.
Can you make a name tag?
I am sassy.
So you wanna,
Make him a bear.
yeah, a quick question about it, or you wanna go through it?
I wanna go through it.
Okay, here we go. No.
I am uber sassy and I talk to my computer.
That was an and statement? Did you?
Oh.
And you talk to your computer? So we're just supposed to find the intervals on which this function is increasing or decreasing.
Excuse the interruption. Please release high school students to the assembly.
That's 5 minutes. Shoot.
Oh, sucks to suck.
Okay,
Let's
to
go.
continue.
Hi.
Hey, quiet. Alright, so the question was Logan's question, right?
Yeah.
And we're trying to figure out where it's increasing or decreasing or both or neither. Or, I don't know. So, the only, let's see, the places where it's increasing or decreasing are going to be defined, like the beginning and the end of where it's increasing or decreasing is going to be defined by what?
0.
Zeros of what?
Slope.
Slope. The derivative, right? Either way.
Did
It's
you
the same.
just like say a bunch of math words?
Well, you have to say a key word for me to continue. So I just threw a bunch of math. I mean, you can say the right answer, but it's like, no, key word, please.
H prime of x. What's H prime?
True.
Come on.
Coefficient derivative.
Negative sine
Of
x
x?
over 2.
X over 2.
And then we got times 1/2.
Times 1/2. Put the 1/2 right there.
Eyeball's attacking itself.
Oh God.
Times the derivative of the inside function, right? We're doing the chain rule. Yeah. I don't want to have
No,
to
doesn't exist.
yell at you.
There's
I
nothing
wouldn't
there.
do it. What's that?
It's undefined.
What's not defined?
X over 2.
X over 2 is not defined?
Well, it would be 1 over nothing. I don't know if 1 over nothing's okay or if it's 1 over 0.
Is that equal 1? Is that 1?
Are you
What are you talking about?
What is going on?
What's the derivative of X over 2?
Oh, well, you can look at x over 2 as 1/2 times x.
Oh. Okay, so it's just 1/2.
1/2. So that's where the 1/2 comes from. Okay,
Oh, that.
what do we do with that derivative?
Equal to
Use
0.
like in
Well,
Set it equals 0, negative 1/2 sine x over 2 equals 0. Multiply both sides by a -2, right? And nothing
Yeah.
really happens. Sine, what is that?
Wow.
There we go.
The sine of x over 2 has to be equal to 0. So,
Well, Tally, you should have factored. Thanks.
Oh, I do have a unit circle.
Yeah.
multiply by 2.
no, sir, no way.
Don't worry, I missed it.
So what?
Sine of 0.
That equals 0.
Oh.
Is that 0?
2 or 0?
Is it X divided by 2?
Oh, inverse sine.
2
Okay,
Oh,
yes, inverse
wow.
sine. Now look, listen please, okay? We're looking for angles. Now these are the angles, x over 2. This value inside these parentheses has to be an angle such that, what? Inside the parentheses, you have to get an angle such that the sine of that angle is 0.
Yeah.
Right? So this value, this quantity in the parentheses needs to be equal to what values have a sign of 0?
What do you get? 0.
Zero.
Get 2 pi.
Get 0,
Pi.
0, pi, 2 pi, 3 pi, 4 pi.
So we're going less than 2 pi.
So between 0 and 2 pi.
So
Okay,
pi.
so at 0 and at pi,
And then 2 pi.
right? And at 2 pi. But
But it's not also including.
So it's just pi.
well, we gotta multiply by 2 here, right, on both sides.
Yeah.
This represents 3 different equations where it's equal to 0, equal to pi, equal to 2 pi. So we multiply both sides by 2, we get x equals 0, 2 pi, and now 4 pi, which
But that
is
doesn't work.
obsolete.
So
Those work.
0 and 2 pi, which would make sense considering the graph.
Considering the graph, we see this horizontal and this horizontal. It's not a good horizontal. My first one is kind of impressive.
Yeah, that first one was great. And then
Okay,
you
there you
go
go.
downhill or.
Huh?
Like, how come it is missing one?
It's so perfect.
It's okay.
Don't mix it up, don't mix it up.
Don't fix it.
No, it's fine. Okay, so in between those two zeros, it must be doing one thing, either increasing or decreasing.
Yeah.
How do we find out?
Plug in a point in between 2 like
Or you
pi.
can just look at the graph.
Like pi or pi over 2 or whatever you want to do. So pi is good. Into the derivative here.
This is
So pi over 2, what's the sign of pi over 2?
1.
1. What's negative 1/2 times 1?
Negative 1/2
Which, what are we to conclude from that?
is negative, which means decreasing.
Negative slope, decreasing. So
It's just.
it's decreasing on the open interval 0 to 2 pi. That whole time. Okay? Are there other questions?
No, I'll see when I return it.
What?
Return it first.
So we don't even know.
Oh, so 80.
Huh?
We don't know if we have.
Do number
80.
Yeah.
80?
last
Might as
one.
well, because what are we going to do? Learn the next section in 10 minutes?
Yeah, I don't think so.
No, thank
Trying to
you.
subtract.
Well,
Take at least 10 minutes.
Does that mean we don't have to
Everybody
hold
just
up
act
this
like
time?
it's done.
Press save.
Where's 80? There you are.
It's after 7.
Quit it. Is that a fact?
That's
Turn around.
Nice work.
Everyone stop annoying me.
Loud noises.
I'm going to remind you that you're in a college level course. This is not how you should act in college, if you're wondering. Okay? We can have fun, but there comes a limit where you should show me that you want to learn this. If you don't want to, then you shouldn't be here, but you're here. So please, govern yourselves. Usually you do well, today you're not. Profit P in dollars made by a fast food restaurant selling X hamburgers is given by this. Okay, so the profit P given X number of hamburgers does that function. So that's only valid for number of hamburgers between 0 and 35,000. Find over intervals on which P is increasing or decreasing.
So a good start
do the
is
derivative.
find the derivative, which.
2.44 minus 2x, or it's going to be x over 10,000. Right? Or do you have to do that?
No, I gotta do that first, you gotta do the quotient.
No
Constant
quotient
scale.
rule.
You can make it
Product.
x.
What we really have here is 1 over 20,000 times x squared. Simple as that.
Yeah. And then you could use the, the power rule,
Uh-huh.
and then make it 2 over 20,000.
Which is?
1 over 10,000.
Times?
Times x.
So x over 10,000.
How did you?
Yeah, can we go over that?
Just wrote this instead of x squared over 20,000, just wrote it as 1 over 20,000 times x squared.
Yes.
Yes?
Yes.
Makes sense?
Oh, then you.
Then we use the power rule, 2 times the coefficient, 2 times, well, 2 divided by 20,000 is going to simplify to 1 over 10,000. 1 over 10,000. Then we take 1 away from the power, 1 away from this power, you get x to the first. What we wind up is with is 1 over 10,000 times x, or x over 10,000.
Okay.
Minus 0. Find the open intervals on which x is, or it's not, xp is increasing or decreasing, so what do we do?
Set it to 0.
Set it to 0. 4 minus x over 10,000. 0, so x over 10,000 equals 2.44 multiplied by 10,000.
Wait, that's
Negative.
negative. Negative.
No, cause you add
No.
x over 10,000 to the other side, not subtracting.
So 24,400, when x is 24,400, that's where we get a 0. There. So that's where the original function does what?
Either repeats or
Where it
minimizes or
has the
maximizes.
slope.
Maximizes or minimizes, yeah. Okay. So is it increasing up until that point, or is it decreasing up until that point?
Let's
find out.
So
So how do we find out?
plug a point in to the left or right of,
All right.
would it be 24,400?
Yeah.
You multiply this by 10,000, you move the decimal place over 4 places.
No, I meant like, would
By
that be
X
the
out.
point you plug in? Like something to the left or right of that?
Yes.
Yeah.
To the left or right of that, yeah. If you plug this into the derivative, you'll just get 0. 'Cause
Oh, I was just freaking out because I thought that was a big number, but I guess you still could just do like 1.
you can do 1, you can do 0,
Okay.
right? 0 is on the interval. So you can plug in 0 into the derivative. Really, really easy. You just get 2.44. What's the significance of finding 2.44?
In positive. That.
Positive, that's it. Just that it's positive means it's increasing. Okay, so you can set up a little table here and say from 0, since that's the interval we're working off of, 0 to 24,100. F prime
Increasing.
is positive. So the conclusion is the original function is increasing. Okay, and after that, from 24,400 to 35,000.
Why you gotta be negative increase?
Well,
Can we just use?
you can't assume that. I mean, we know that it's going to be like a parabola.
How about we do 10,000 then?
Huh?
How about we do 10,000?
We need to find.
If we did 10,000, no, we already have a
Oh,
point
wait,
that's to the
never
left
mind.
of 24,400.
Yeah, I know.
That's a good idea because you get 1.
Yeah.
You got 30,000.
If we do 30,000, we'll come out with a 3.
Yeah.
That'd be helpful, right? So 2.44 minus 3 is negative. So we get decreasing. So what can we conclude about that? I mean, it doesn't even ask, but what can we conclude about 24,400 in the context of this problem? This hamburger.
Maximum.
So
It's when it's
That's the
the
maximum.
Profit?
maximum profit. So we're making 24,400. It doesn't really say in a month or a year or what. But go beyond that and you start to not make as much money maybe because you have to store all that stuff. Whatever. Maybe what you need to do at that point after you're not making that much money is open another store or something like that, so that you actually can handle that volume.
And another store, how would you change the equation to find maximum profit to people
You get that? It's gonna be like.
You don't know.
I'm not the profit analyzer.
I feel like the real word.
Yeah, well, yeah. That's
What's over?
any other questions? Zadie, did we miss any part of that question? Seems like they would have asked more than that. No? Let's go.
Another one.
80? No? That's it. Okay, I got all your homeworks already?
Yeah, mine is here now.
Okay, I want yours.
I'm gonna go out and show that I don't have.
That looks like it's it. If you don't have it, yeah, we